Alright, so before we get to the simulation, we will start by a little example of how we can blend two geometries. And to blend two geometries, it is necessary that the two geometries have a similar point counts or prim numbers, okay? So we will start with the geometry network. So this geometry network you can call sim and you can change the color. Inside we will create a sphere, and this sphere is going to be a polygon. Change the frequency type to 25, so we have a lot of points here, a lot of triangles. This way we can shape it properly. We'll create a mountain node now, and with the help of the mountain node we will create the rock shapes. So come to the mountain node and change the noise pattern to Whirly Cellular F1, and this way we'll get a rock. Okay, this is looking nice. We'll change a little bit here. So maybe change the element size a bit, maybe 1.1. Okay, maybe, yeah, this is looking nice. And then we have a good shape here, but we will just copy another mountain node here, and this will be a Whirly Cellular F1 as well, but will decrease the element size here. All right, so let's change the element size so that we'll get more minute details. So it is affecting a smaller area now, and will also decrease the amplitude because this is too much. So let's keep the amplitude to 0.005. So this way you can see, if you go to the earlier mountain node, this is the rock shape that we are getting, and we wanted some more detail here, the little details. That's why we have added another mountain node. We have our rock shape. This is looking nice, and what we can do is we'll create another sphere shape, and then we are going to use a ray node to reshape that sphere into this. Okay, so we have another sphere here. We'll change the polygon, change the perimeter type to polygon, change the frequency to 25, and we are going to use a ray node. Change the method in ray node to minimum distance and turn off the show guide geometry. So this is what we are getting. We have reshaped the sphere into this into this rock. All right, this is our sphere and this is our rock, and we have reshaped this sphere into this rock with the help of the ray node. Okay, all the points or all the primitives in this sphere are looking for the closest distance on this rock. All right, and then they are changing their position to that specific closest point or closest distance. Okay, so all the primitives on the sphere are looking for the closest distance or the closest surface on the rock, and then they are transforming themselves, or they are changing their position to that surface. Okay, so this is how we are getting this sphere which is transformed into this rock shape. So as I said earlier, that if you want to blend two geometries, one of the main rules is that the point count and the perimeter count needs to be same for the two geometries. All right, so we have a sphere and now we also have a rock, and we can blend between the two. All right, so let's use a blend node here. So this is our blend shape node, and we want to blend between the sphere and the rock. All right, so come to the blend node, and if you change the offset here of the blend, you can see that the rock is changing or blending into the sphere. And this rock we obtained by reshaping the sphere, and this is our sphere. So both of them have the similar point count and the prim count, so we can blend between these two geometries. This is our rock, and when we are changing the offset, we are getting the sphere. All right, one thing I need to do before we move forward is that after the sphere, one thing I need to do before we move forward is that I need to apply some UVs. So I'll use a UV project node on the sphere, and this way we are getting our UVs, but I'll change the projection type to polar, and this is looking better. So we have our sphere and we have our rock with the UVs on it. all right, and we can obviously blend between them. So this is a simple example. This is not we are going to, this blend shape is not what we are going to use, but for your understanding, this was that. So let's move ahead. I'll delete this blend shape, all right, and what I need now is I need to create a line. So I'll create a line here. I'll move the line a bit in the y direction, something like this, and I'll change the point count to 5, all right, and I'll also change the length here to maybe 1.75. I wanted it to be a bit longer. Yeah, this is looking nice. And what we can do now is we will resample this. We'll resample this line, but we do not want to change any of the point counts here. So the only thing that we want here is curve view attribute. So we are using this resample node just to get the curve view attribute. And if we visualize that curve view attribute, you can see that we have a curve view attribute here, which is going from 0 to 1. All right. So that is that. And after that, I'll just use a copy to point node. I'll bring this here a little closer. We'll use a copy to points node, and we will copy our rocks onto all these points. Let me turn off this. So this is what we are getting. We have all our rocks. There are 5 rocks here, and as we had 5 points here, as you can see, there are 5 points, and all those 5 points are getting our rock. We are copying these rocks onto our points with the help of the copy to point node. The shapes here, the size here are too big, so we'll control that with the help of a scatter and align node. All right. In the scatter and align node, we will change the mode to add attributes to existing point cloud. Still, we are not getting anything, so we'll connect the second input here as well. And now we can control the size of this. So let me change the minimum radius here a little bit. So okay, I changed the minimum radius, and I want to increase the rotation. I want all of them to rotate in a different direction. So I'll change the maximum random cone angle here to, yeah, around 140. Okay, this is looking nice. And I'll change the angles here as well. Okay. And we want all of these rocks to rotate every frame. We want them to rotate constantly. So what I'm going to do is I'll just apply add frame here, so that each frame they are going to change their value. The offset angle is going to be change every frame, and this is going to be equal. The offset angle is going to be changed every frame, and the angle amount is going to be equal to the frame. We'll come to frame 1, and you can see now you must be thinking that they are all intersecting, and we do not want that. Obviously, I'll change that. I wanted to control it a little bit better. So we'll use an attribute wrangle. I'll change the P scale value with the attribute wrangle. Okay, I'll use the attribute wrangle here, and f@P scale, I'll multiply it by 0.5. So we are halving the P scale value. The size of the sphere of the rocks is half now. All right. If you play this, you can see that all of them are rotating, which is nice. So we have our, so let's recap. We created our rocks, and then we created a line here, and then we copied all the rocks on those points. All right. We want to blend this rocks with sphere. Okay. So what we are going to do is we need to create spheres here. We'll create another copy to points node, And this time, instead of copying the rocks on these points, we'll copy the sphere. So this is what we are getting. All right, we have our rocks and we have our spheres. So if I use the blend node together, so if we use the blend node again, the blend shape node, you can see initially all these points are rock, and when the blend factor increases to 1, they all change their shapes to spheres. I just delete this. So this is working fine, but one more thing that we need to do is I want to create a growth attribute here. So that growth attribute is going to go from top and it will go to bottom. There are different ways, but my favorite way that I have covered in my previous videos as well. So as you would have seen, we are going to create an attribute triangle. So we already have a curve view attribute that we created on our resample node. Come to attribute triangle here. All right, and now what we are going to do is we will create our growth effect. So for that, I'm going to create a mask variable which is going to be equal to curve view. Okay, so and this mask is going to be equal to the mask attribute, so that we can visualize this mask attribute. Whatever we are doing, we would be able to visualize this. And connect this here as well to this one. Okay, let's visualize the mask attribute. Let me change the color to grayscale here. Okay, and let's turn off the textures so you can see it properly. Okay, so this mask attribute, which is based on curve view attribute, is going from 1 to 0. Okay, so the black color represents the 0 and the white color represents the 1. So we are getting a value from 0 to 1. If I offset this value, if I add some offset here, so mask plus equals an offset, I just press this button, create a spare parameters so that we get our channel offset. So we have our channel offset here. So if I increase the offset here, you can see that initially it is going from 0 to 1, and if I increase the offset to 1, you can see that all the values are turned up now. All the values are turned up. The one that had a value of 0 initially, like this, the black represents 0. This one had a value of 0, and now I have added 1 to this. So the value have increased to 1. And this one, which already had a value of 1, it would have increased to 2. If you want to see that, then I can change the type to marker. And now you can see that the topmost sphere has a value of 2 now, as we have added 1 here. Okay, and the bottommost sphere, which had a value of 0, has a value of 1 now, the mask attribute value 1. Okay, and if I bring the offset to 0 again, then this is going to be 0, and the topmost one is going to be 1, as 1 added to 0 is 1. All right, what I'm going to do is I'll change the range for this offset. I'll come to edit parameter interface here, come to offset, and the range is from 0 to 1 here. So I'll change it to -1 to 1. All right, I'll apply this, accept, and now you can see that this offset can go from -1 to 1. So let me change it back to color. All right, so initially when the offset is 0, that means we are just adding 0 to the mask, which is based on curve view attribute. Then the values are same, they are not changing. Okay, it's going from 0 to 1. When we added 1, then this one gets a value of 1 and this becomes 2. What will happen if we add -1 to all of these? So let's see. This is what we are getting. the sphere which had a value, mask value of 1 is now subtracting 1. So we are getting a value of 0, and the one that had a value of 0 would be minus 1. If you want to visualize that, change it to marker, and you can see the bottommost sphere has a value of minus 1 now. Initially it had a value of 0. When we added 1, it becomes 1. When we added minus 1, it becomes minus 1. And similarly for the topmost, when it had a value of 0, then it was 1. And when we added 1, it becomes 2. And now that we have subtracted 1 here, it becomes 0. Okay. So I'll keep it at 0 and I'll change the visualization to color. Okay, so the values now are going from minus 1 to 2. Okay, the values for these spheres are going from minus 1 to 2. We do not want that. We are going to clamp that. So mask is going to be equal to clamp. We are going to use a clamp function. And what we want to clamp? We want to clamp the mask. And this is going to be clamped from 0 to 1. Alright. So this is what we are getting. All the spheres now have a minimum value of 0 and the maximum value of 1. Alright. So this values for mask attribute is going from 0 to 1. And now we have a growth effect here. As you can see, initially all of them are going to be 0 when the offset is minus 1. And then when we animate this, we can switch this, we can set this offset as, we can animate this offset value here. When we increase the value to 1, all of them becomes 1. Okay, so this is going to be our growth effect. This is looking nice. All right. And we are going to use this mask attribute for the blending of our geometries. We will blend the rock shape into a sphere shape with the help of this mask attribute. Okay, wherever the mask value will be 1, that will turn into a sphere. So initially everything will be rocks and then it will change to spheres. Okay, now what we are going to do is we will blend all of these. We will use an attribute triangle and we will connect our rocks and our spheres here to the attribute triangle. And instead of using the blend shape node, we are going to use this attribute triangle and we will use the lerp function to blend our geometries. All right. So the first thing that we need to do is we need to have the position for all of these, for both of these. We have a position of our rocks here, which will be P. P stands for position. And we will need to have the position values of all these spheres as well for all the points here. We need to have the position value for all the points of the spheres as well. All right. So we'll come to attribute triangle, and before we can use the lerp method, what we are going to do is we will find the position values for all the spheres. So let's create a vector variable called pos, and this is going to be equal to the point function, and this point function is going to read values from the second input here, input 0 1. So we'll use 1, and we need to read the position values, so that's why position values, that is position attribute. So we will use the P here, and we need to read the position attribute, position values of all the points which are coming from the second input. All right. So what is happening here? Let's go again. We already have the position value of all the rocks, as this rocks are connected here to the input 0. Okay, we already have the position of all the points on these rocks. All right, but we need to have the position values for all the points on these spheres so that we can blend between all these geometries. All right, and that is why I have used this point function here, and that point function is equal to a vector variable called pos. We need a vector variable because position is a vector attribute. So we have a vector variable called pos, and that is equal to the point function. And what this point function is doing is it is reading all the position of the points which is coming from the second input. Okay, this point function is basically reading the point attribute of all the points which is coming on the second input. So we are getting the position value of all the points on the spheres. Alright, I hope this is clear. After this, we will create another vector variable called poseRock, and this will be equal to the position P, the P attribute. So this poseRock is equal to the P attribute of all the points on the rock. Okay, and now we can use our lerp method. So what we are going to do is our position is going to change. Okay, so our position is going to be equal to lerp. Lerp basically means blending. All right, so we are blending between these two positions. So position one is going to be poseRock, the position of the rocks, and we are going to change the position to spheres. And what we are going to use to change the sphere, we need to use a factor. We can create a channel float, but we already have a mask attribute, so we are going to use that mask attribute as a blending factor. All right, so let's see. Why is this not happening? Oh, all right, we have not animated our mask here. Okay, so come to attribute wrangle, and this is important. We need to animate this offset. So at frame 1, this is going to be -1, and at frame 155, it is going to be 1, as our animation is going to be running from the frame range 1 to 150. So you can change the animation frame range as well to 150 here. And now, if I visualize the mask here, you can see initially it is black. The mask attribute is going to be 0, and then as the animation progresses, all of them are going to be white, which means the mask attribute has a value of 1 here. And here at the attribute wrangle, we have our position for the rocks, which is poseRock. Okay, and we have position for the spheres, and we have used the point function to get those position, and we are blending between those two positions with the help of the mask attribute. Okay, and we have used the lerp function for that. So whenever the mask attribute has a value 0, that means at that point we are going to use the poseRock. We are going to be using the poseRock for the point position, and when the mask attribute increases to 1, we are going to use the position of the spheres. All right, so if I run this animation now, you can see initially all of them are rocks, and as the animation progresses, the geometry is blending to sphere, and this is what we wanted. But we can create something even better. So I'm going to use a attribute remap node here. Okay, and in the attribute remap, what we are going to remap is mask attribute. And what I want is, I want all of them to be rock initially, then for a brief moment I want all of them to turn to spheres, and then again I want them to turn to rock. And for that I'm going to use a attribute remap here, and I will manipulate the mask attribute here. Okay, so let's bring changes to mask attribute with the help of this ramp. I'll bring this first point to somewhere here. Okay, so initially the mask attribute is going to be 0, and then it will completely increase to 1. Okay, and this will stay for a few moments, for a few frames, and then we will bring it back down to 0 like this. So what this ramp is doing is, initially the mask attribute is going to be 0, then it will go to 1, and it will stay there. It will stay 1 for a few moments, for a few frames, and then it will come down to 0. Okay, and we can change the interpolation here to B-spline, so this is more smooth. And now We'll connect this copy to points here to the attribute remap so that both the sphere and the rocks have same mask value. Now when we run the animation, you can see they turn to sphere and then they go back to rocks. So initially they are rocks, then they blend to become a sphere, and they stay there for a few frames, and then they go back to being a rock. And this is what we wanted.